Welcome back to Triple E tutorial channel. Now here in this video we will focus that why a single phase induction motor is not self-starting. Through this video we will focus on the reason behind this. Okay, so here you can see the construction of a three-phase induction motor. Already we have discussed the construction and working of three-phase induction motor in detail in my previous video. For more reference, you can refer that video. In the description box, I will share the link. Okay. When we think about the reason behind why a single phase induction motor is not self-starting, before moving on to that topic, when we talk about a three-phase induction motor, we know that there we are giving a three-phase supply to the stator winding. When we give a three-phase supply to the stator winding, we know that the three-phase windings or the three windings in a three-phase induction motors are connected as 120 degree apart from each other. 120 degree apart from each other. Due to this reason, we are giving a three-phase AC supply. What will happen? A magnetic field which will produce in each windings because of the net effect of these three magnetic fields, we will get a resultant magnetic field and which is rotating in nature, and the speed of the rotating magnetic field is known as synchronous speed. Okay, the magnetic field which is rotating in the synchronous speed will cut the rotor, and an EMF will induce in the rotor. Because of the closed construction of the rotor, a current will flow through the rotor, and due to this current flow, a rotating magnetic field which will create in the rotor winding, and the net effect of, or due to the interaction of these two magnetic fields, that is, first magnetic field is produced by the stator winding and the next is produced by the rotor winding. Because of the net effect of these two magnetic fields, what will happen? A torque will generate in the rotor and the rotor will rotate in the required direction. This is the basic working of a three-phase induction motor. So simply we can say a three-phase induction motor is, obviously it is self-starting. There is no need for any extra setups for a three-phase induction motor. We turn on the supply, the motor will starts in the required direction. So this is the basic principle of a three-phase induction motor. By considering this, we can discuss about a single-phase induction motor. That is, here you can see the basic just construction of a single-phase induction motor. We know that in a single-phase induction motor, there will be a stator and there will be a rotor. First of all, we are giving a single phase AC supply to the, since we are discussing about the single phase induction motor, so first of all we are giving a single phase AC supply to the stator winding. We are giving a single phase AC supply. So then what will happen? It will provide an alternating magnetic field, not rotating, but it will provide an alternating magnetic field. Otherwise we can say a pulsating magnetic field. During each cycle, the direction will be changed. During the positive cycle, the direction of the induced EMF will be in a particular direction, and in the next instant it will be just reversed because of the alternating supply, or because of the production of the alternating magnetic field in the stator. Okay, so we can discuss about the working. When we are giving a single phase supply to the stator windings, then obviously it will provide, or it will generate an alternating magnetic field. This alternating magnetic field produced by the stator windings will cut the rotor, and an EMF will induce in the rotor according to the Faraday's law. So it is produced EMF in the rotor magnetic field will leads to the flow of a current through the rotor, and due to the flow of current through the rotor, an EMF will induce in that rotor. That means a flux will induce in the rotor windings because of the flow of the current through the rotor windings. So the direction of the magnetic field induced in the rotor windings will be also a pulsating one, or it will be an alternating magnetic field. So what will happen? Because of the production of flux in the rotor magnetic field, a torque will generate. Because of the net effect of the two fields, it will just rotating in any particular direction. At the same moment or at the next moment, what will happen? We can say simply it is in the negative cycle or something like that. And in the next moment, the direction of the field just reversed. In the stator field winding, the produced flux will just reversed, and at the same time what will happen, an EMF will induce in the rotor in the reversed direction, and also torque will be, or the flux will produce in the rotor in the reverse direction, and the torque will also get reversed. So entire process will get reversed in the next cycle, next half cycle. So each half cycles the production of the torque will be changing. Due to this change, the single phase induction motors will not rotate any particular direction. They will be just in this direction, and in the next cycle it will be in the reverse direction. So forward and reverse movement. So finally we can say the motor will not start. It will be staying in the standstill position. So a single phase induction motors are not self-starting. So to make it starting, we have to convert this single phase induction motors into a two winding motor, or any other starting methods that we can provide to make a phase difference. For the case of a three phase induction motor, 120-degree phase difference are there. But in the case of a single phase induction motor, there is no phase difference. So we have to create a phase difference. We will provide additional setups in the stator winding. Then we can make the single phase induction motors as self-starting by providing some techniques. Okay, so this is the basic principle of single phase induction motor that we have discussed why it is not self-starting. Okay, here I have added some text based on the reason why the single phase induction motors are not self-starting. You can refer this portions. Okay, so by providing extra setups to the stator winding, we will make a double fields or we will make a phase difference, or we will make a two fluxes on the stator field winding, that is double field revolving theory. Sorry, in the coming lessons we will discuss about the double field revolving theory. What is the need of it? Already we have discussed. If there is a phase difference, it is easily we can make a rotation in the single phase induction motor. So thank you for listening. Okay.